Good morning, everyone. Today we're going to be going over some more basic trigonometry that we use very often in physics. So today we're going to be looking at sine, cosine, and tangent and how we solve for our angles and sides in a right angled triangle. So here we have a right angled triangle. Let's say that this is the angle that we are interested in. So this side here that's opposite the right angle is your hypotenuse. I'm just going to abbreviate it as HYP. This angle here, this side here, right next to the angle, this is your adjacent. So I'm going to just abbreviate it as ADJ. And then this side that is opposite the angle here, it is called your opposite side, and I'm going to abbreviate it as OPP. So depending on the sides that we're given or the angle, we can do a number of calculations to determine our missing values. So I like to use what we call SOH CAH TOA. Now, SO is the first one. It is sine of your angle is equal to the opposite over the hypotenuse. CAH is cosine of your angle is equal to your adjacent over your hypotenuse. And TOA is tan of your angle is equal to the opposite over the adjacent. So you can see that we have different formulas and we can use them to solve different things. So let's take a look at a couple of examples. So if we have this right triangle right here, and we know that the angle here is 20 degrees, and this length here is 10 meters, we want to know what is the value of my length R. Now it's important to identify what each of these things are. So this right there, that's my theta. This one, it's the length opposite my angle. So this is actually my opposite. And we're looking for my hypotenuse. So if we take a look at these formulas, we're going to need to look to see which one has opposite and the hypotenuse, which gives us sine. So sine theta is equal to, it's equal to the opposite over the hypotenuse. So if we were to plug things in, we're going to replace the theta with 20. We're going to replace the opposite with our 10. And our hypotenuse we're going to replace with R. So we don't know what R is, so we need to isolate for R. And the way that we would isolate for R is we would do cross multiplication. So this is over 1. We would multiply up like this. So this becomes R sine 20 is equal to 1 times 10. It's just 10. And to get R completely by itself, we're going to want to divide both sides by sine 20. Remember, when we divide by the same thing, it cancels out. So if I would to clean this up here, I would find that my R is equal to 10 divided by sine of 20. And then from there, I can do my calculation, which if I were to plug this into my calculator, I would find that my hypotenuse, or my length R, is 29.24 meters. And remember, I keep the unit there because I had meters in my length over there. All right, let's take a look at another example. So I have this right triangle here, and I have this length is 5 centimeters, this length is 4 centimeters, and my angle right here is my unknown. So this here, this is the length opposite the right angle, so this is the hypotenuse. This length here is the one right beside this angle, so this is my adjacent. And I am missing my theta, so I want to calculate what my angle is. So if I look at my formulas, I'll see that my cosine is the one that I want to use because it has the adjacent and the hypotenuse. So cosine of theta is equal to the adjacent over the hypotenuse, and then I can go ahead and plug them in. So adjacent is 4, and then the hypotenuse is 5. So from here, I'm going to want to do this division here. 4 divided by 5 is going to give me 0.8. Now I need to isolate my cosine, my angle I should say. And the way that I do that is I bring this cosine to the other side. Now, when you bring it over to the other side, you have to use the cosine to the -1 operation on your calculator. So that's probably when you push second function cosine, you would get this. And then you would type in your 0.8. And if you were to type this into your calculator, you should get an angle of 36.9 degrees. All right, now I'm gonna do another example, but I want you to try it out first. So here is our right triangle. This is the right angle in here. We know that this angle in here is 30 degrees. This length right here is 15, and this is our x. So pause the video, take some time, try and solve for x. All right, let's take a look at the solution to this problem. Again, we want to identify each of these things here. So this side here, the x, is opposite our angle. So this is our opposite. This length here is right beside it. So this means that this is our adjacent angle, or length, I should say. And then this is our theta. So looking at these formulas, we notice that tan is what we want to use. It has the opposite and the adjacent. So let's plug things in now. Tan of 30 degrees is equal to my opposite, which is x, over 15, which is my adjacent. To isolate for x, we're going to cross multiply. So remember, put that over 1, and then we're going to multiply up. So this is going to become 15, 10, 30, and 1 times x is just x. We can rewrite this formula so that x is on the left-hand side. And then from here, we just have to solve and plug this into our calculator. And when we do that, we should get an answer of 8.7. That is all I wanted to talk about with you today. And I will see you next time when we start a new topic, the topic of vectors.